What if I told you that underneath your feet, right now, in the dirt beneath your lawn, your garden, your driveway, there's enough electrical energy to power lights, charge batteries, and run small electronics, and all you need to pull it out is $8 worth of metal from a hardware store. No solar panels, no wind turbine, no lithium. No monthly bill, just 2 pieces of metal, some dirt, and a bucket. That is an earth battery. It was invented in 1841. It powered telegraph lines across entire continents for decades. One man even used it to make wireless phone calls 11 years before the first commercial radio broadcast. And then, somehow, it vanished. Gone. Erased from every textbook, every engineering course, every mainstream energy discussion. A technology that produces free electricity from the ground, that recharges itself naturally, that uses no fuel and creates no pollution, and nobody talks about it. So today we are going to build one, test it, explain exactly how it works, and most importantly, answer the question that nobody in the power industry wants you to ask. If dirt can generate electricity for free, why is your electric bill $163 a month? Let us start with what an earth battery actually is, because the science is not complicated. It is not free energy nonsense. It is not a scam. It is not a perpetual motion machine. It is basic electrochemistry, the same chemistry that powers every single battery you have ever used. An earth battery is simply 2 pieces of different metals buried in the ground. That is it. 2 metals, some soil, some moisture. The soil between them acts as what scientists call an electrolyte, the same role that the acid plays inside a car battery or the lithium solution plays inside your phone battery. When you stick a copper rod and a zinc rod into moist soil, something happens immediately. The zinc, which is what chemists call a more reactive metal, begins to release electrons. Those electrons want to travel somewhere, and that somewhere is the copper rod, which is less reactive and happier to accept electrons. Connect a wire between the 2 metals above ground, and those electrons flow through that wire. Flowing electrons is literally the definition of electricity. Congratulations, you just generated power from dirt. A single cell, 1 copper rod, and 1 zinc rod in a bucket of soil will produce somewhere between 0.8 and 1.1 volts. That number comes from a 2021 peer-reviewed study published in Energy Reports by researchers who built and tested multiple earth battery configurations. A single cell produces roughly 1 volt at around 25 to 30 milliamps. That is a tiny amount of power. But here is where it gets interesting. If you connect multiple cells in series, which just means linking the copper of one cell to the zinc of the next, the voltages add up. 4 cells give you roughly 3.7 volts. 12 cells wired in series push you past 12 volts. In that same study, researchers built a standard series parallel configuration of 25 cells using carbon and aluminum electrodes and achieved a stable 6 volts DC at 0.1 amps. That is 0.613 watts of continuous power. Enough to run LED lights, charge a phone through a USB adapter, or power small sensors and radios. 25 cells, plastic containers you can get for free, electrodes that cost a few dollars total, soil from your backyard, water from your hose. Total cost under $10. Now, I know what you are thinking. Half a watt. That is nothing. My microwave uses 1,200 watts. And you are right, we need to be honest about this. An earth battery is not going to run your air conditioner. It is not going to power your refrigerator. It is not replacing your entire grid connection tomorrow. But here is what the power industry does not want you to understand. Half a watt, running 24 hours a day, 365 days a year, with 0 fuel cost and 0 maintenance cost, adds up. And more importantly, there are applications where half a watt to a few watts is all you need. Garden lights, security sensors, weather stations, emergency radios, trickle charging for deep cycle batteries, fence chargers for livestock, trail cameras, small fans for ventilation in off-grid shelters. In a grid-down emergency, a 12-cell earth battery producing 12 volts could keep a ham radio alive when nothing else works, and it runs on dirt. But power output is only half the story. The real magic of an earth battery is its lifespan. The researchers in that same 2021 study observed something remarkable. When they disconnected the load from their earth battery in the evening, the voltage recovered. It recharged itself naturally within 3 hours. The soil is not just an electrolyte. It is a living chemical environment. There are dozens of naturally occurring metal ions in soil: silicon, aluminum, iron, calcium, sodium, potassium, magnesium. These ions are constantly participating in chemical reactions. Bacteria in the soil are breaking down organic matter and releasing electrons as part of their metabolic process. There is a whole field of science called microbial fuel cell research that studies this exact phenomenon. Researchers at institutions around the world have measured power densities of 44 to 485 milliwatts per square meter from soil bacteria alone. The ground beneath your feet is a living, breathing electrochemical reactor. An Earth battery simply gives those electrons somewhere useful to go. This is not new science. This is not fringe science. This is 183-year-old science. Alexander Bain, a Scottish inventor, built the first documented Earth battery in 1841. He buried plates of zinc and copper about 1 meter apart in the ground and used the resulting voltage, roughly 1 volt, to operate a clock. That clock ran continuously, no winding, no external power, just dirt. Bain went on to patent multiple telegraph devices powered by Earth batteries. His 1848 U.S. patent number 5957 describes using the natural agency of water and earth as a power source. Think about that. In 1848, a man patented a system for pulling electricity from the ground, and the United States government said yes. That is a real invention. Here is your patent. But Bain was just the beginning. Throughout the 1800s, Earth batteries were standard equipment for telegraph networks. The entire telegraph industry knew that you could get free power from the ground. Daniel Drawbaugh received U.S. patent 211,322 specifically for an Earth battery designed to power electric clocks. James C. Bryan received U.S. patent 160,152 in 1875 for his Earth battery design. George Diekman got U.S. patent 329,724 in 1885 for yet another design. These were not basement tinkerers. These were professional inventors and engineers who understood that the Earth is essentially a massive, self-recharging battery. And then there was Nathan Stubblefield. If there is one name that the power industry has worked hardest to erase, it is his. Stubblefield was a farmer and self-taught electrician from Murray, Kentucky. In 1892, let that date sink in, to 1892, he demonstrated a wireless telephone powered by Earth batteries. He had a friend walk a short distance away, holding a receiver, and transmitted the words, "Hello," rainy through the ground in the air without a single wire connecting them. On January 1, 1902, in front of hundreds of witnesses in Murray, Stubblefield set up a transmitter in the courthouse square and simultaneously sent voice and music to 7 different listening stations scattered across the town, not over wires, not over radio waves as we know them, through the Earth itself powered by Earth batteries. The St. Louis Post-Dispatch covered the story. Scientific American reported on it. In March 1902, he demonstrated ship-to-shore wireless communication from a steamboat on the Potomac River in Washington. DC voice and music transmitted a third of a mile, and the scientific press went wild. Stubblefield predicted nationwide broadcasting, wireless communication between cities, simultaneous distribution of news and weather. He received U.S. patent 600,457 in 1898 for his electrolytic coil battery. A combination of an Earth battery and a solenoid, he later received U.S. patent 887,357 in 1908 for his wireless telephone system. This man was doing in 1902 what commercial radio would not do until the 1920s. And what happened to him? He was approached by New York promoters who formed the Wireless Telephone Company of America, capitalized at $5 million. But within months, Stubblefield discovered the company was being run fraudulently. He severed ties. The company collapsed. He returned to Murray, broke, discredited, and forgotten. He spent his final years living in isolation in a crude shelter near Almo, Kentucky. When they found his body in March 1928, it had been partially eaten by rats. The newspaper described him as a hermit. The New York Times ran a small obituary, calling him a radio pioneer who died poor and embittered. The man who wirelessly transmitted voice from a steamboat in 1902, powered by dirt, died alone and forgotten because the commercial interests of his time could not figure out how to put a meter on the Earth. And this brings us to the question that really matters. Why don't you know about this? Why is none of this taught in schools? Why does every energy conversation in 2026 revolve around lithium batteries and solar panels and expensive grid-tied systems, when a technology that pulls free power from the ground has existed for nearly 2 centuries? Let us follow the money. The average American household pays $163 a month for electricity as of 2026. According to Electrochemical, the average rate is 18.44 cents per kilowatt. With approximately 132 million households in the U.S., the residential electricity market alone represents hundreds of billions of dollars per year. That money flows to utilities, to battery manufacturers, to solar installers, to inverter companies, to the lithium mining operations in Chile and Australia and the Democratic Republic of Congo. Every dollar you spend on your electric bill is a dollar that someone in that chain pockets. An earth battery costs $8, runs on free dirt, produces no recurring revenue for anyone, and requires no subscription, no monthly payment, no app, no firmware update, no warranty plan. From a business standpoint, it is the worst product in the world because it actually works and then it is done. Now let us talk about lithium, because the contrast is stunning. To extract 1 ton of lithium requires approximately 500,000 liters of water, according to Columbia University's State of the Planet report. In Chile's Atacama Desert, lithium mining has consumed 65% of the region's water supply, devastating local farming communities. Lithium mining produces an estimated 1.3 million tons of carbon emissions annually, according to Earth.org. The cobalt in your phone battery and your Tesla Powerwall is largely mined in the Democratic Republic of Congo, often by children. And after all that environmental destruction, what do you get? A lithium battery that degrades over time. Every charge cycle reduces its capacity slightly. After 10 to 15 years, it is spent. FDNY reported 900 fires attributed to lithium-ion batteries since 2020, causing 500 injuries and 34 deaths. In 2024 alone, according to FSRI data, there were 3,880 incidents, 586 injuries, and 104 deaths linked to lithium-ion batteries nationwide. An earth battery uses zinc and copper. Zinc is the 24th most abundant element in Earth's crust. Copper is everywhere. Neither is toxic. Neither is mined by children in war zones. Neither catches fire. Neither degrades with cycling in the same way lithium does. Galvanized steel, which is just zinc-coated steel, lasts 35 to 50 years buried in aggressive soils and 75 years or more in less corrosive conditions. According to the South Atlantic LLC corrosion data, the zinc anode in an earth battery will eventually corrode, but we are talking years, not months. And when it does, you replace it for about $2. Try replacing a Tesla Powerwall for $2. But let me be completely fair. Let me give you the honest limitations, because unlike the power companies, I am not trying to sell you something. An earth battery has real constraints. First, the power output is low. A single cell gives you roughly 1 volt at 25 to 30 milliamps, that is milliwatts of power. Even a 25-cell array only produces about 0.6 watts. To power serious appliances, you would need hundreds of cells, and at that point, a $150 solar panel honestly delivers more watts per dollar. Second, earth batteries are moisture dependent. When the soil dries out, the electrolyte function weakens and voltage drops. In the 2021 study, researchers noted they added 0.1 liters of water to each cell every 6 weeks to maintain performance. If you live in an arid climate, you will need an irrigation strategy. Third, the zinc anode does corrode over time. That is the fundamental chemistry. The zinc sacrifices itself to produce electrons. You cannot get something for nothing in thermodynamics. But the replacement is cheap, simple, and produces no toxic waste. Fourth, internal resistance is high, which means the voltage you see on a multimeter with no load connected drops significantly when you actually plug something in. The open circuit voltage is always higher than the working voltage. This is why videos showing 12 volts on a multimeter can be misleading if they do not show voltage under load. Those are real limitations. But they do not change the fundamental fact that earth batteries work, that they have worked since 1841, that they powered telegraph networks, that they enabled wireless communication, and that they were systematically abandoned not because the technology failed, but because it could not be monetized at scale. Now, let me tell you about the ancient world, because the Earth battery might be even older than Alexander Bain. In 1936, near Baghdad, Iraq, archaeologists discovered a clay jar containing a copper cylinder surrounding an iron rod, sealed with bitumen. It dated to the Parthian or Sasanian era, roughly 250 BC to 650 AD. When researchers filled replicas with vinegar or grape juice as an electrolyte, the jars produced between 1.1 and 2 volts. The Mythbusters television show built 10 replicas, connected them in series, and got 4.33 volts, enough to visibly electroplate a copper token with zinc overnight. Now, the academic community debates whether the Baghdad battery was actually used as a battery. Many archaeologists argue it was a container for sacred scrolls or magical spells. That debate is real and unresolved. But what is not debatable is the chemistry. A clay pot, 2 dissimilar metals, and a liquid electrolyte will produce electricity. It does not matter whether the Parthians knew what they had. The physics works regardless of who understands it. So here's what you can build this weekend. Go to any hardware store, buy a 4-foot piece of 1/2-inch copper pipe that runs about $3 to $4. Buy a 4-foot piece of galvanized steel pipe or a pack of large galvanized nails. That is another $2 to $3. Cut each pipe into 6-inch sections. You now have enough electrodes for 8 cells. Get 8 plastic cups, old yogurt containers, or any non-conductive containers. Fill each one with soil from your yard. Rich, dark, slightly damp soil works best. Clay soil and decomposed organic matter give the highest ion density and conductivity. Push 1 copper section and 1 galvanized steel section into each container, about 2 inches apart. Make sure they do not touch each other underground. Add just enough water to make the soil damp but not flooded. Now connect them in series. Run a wire from the copper of cell 1 to the zinc steel of cell 2. From the copper of cell 2 to the zinc steel of cell 3, and so on. At the end of your chain, you will have 1 free copper electrode and 1 free zinc electrode. Those are your positive and negative terminals. 8 cells in series should give you somewhere between 6.4 and 8.8 volts, depending on your soil composition, moisture level, and electrode size. Connect an LED directly, and it will light up. Use a small boost converter, about $2 on Amazon. And you can step that voltage up to a stable 5 volts for USB charging. Add a small rechargeable battery pack as a buffer, and you have a self-sustaining power station that charges itself from the ground 24 hours a day for the cost of a fast food meal. If you want more power, scale up. The 2021 research study achieved 12 volts and 0.06 amps with 37 cells in series parallel, configuration enough to run small DC fans and multiple LED bulbs. Use larger electrode plates instead of rods, and you increase the surface area, which increases current. Use mineral-rich soil, or add a small amount of salt to increase conductivity. Bury the cells in the ground instead of pots, and you tap into naturally stable moisture and temperature. The deeper you go, the more consistent the performance. Because underground temperature and moisture fluctuate less than surface conditions. 183 years ago, Alexander Bain ran a clock on dirt. 133 years ago, Nathan Stubblefield made wireless phone calls powered by dirt. Today, peer-reviewed research has confirmed that 25 cells of soil can produce stable, continuous DC power with natural self-recharging capability. And yet, in 2026, the average American sends $163 every single month to a power company, charges their phone with lithium mined by children in Congo, and has never once heard the words Earth battery in any school, any news broadcast, or any mainstream energy discussion. You are now one of the people who knows. You know the history, you know the science, you know the patents, you know the names Bain, Stubblefield, Brian Drawbaugh, Dickman. You know the chemistry. Zinc gives up electrons. Copper accepts them. Soil carries the current. You know the cost $8. You know the fuel, dirt and water. And you know why nobody told you? Because free electricity from the ground does not generate quarterly earnings for shareholders. Build one this weekend. Test it, measure it, see the voltage with your own eyes. Then ask yourself one question. If $8 worth of metal in a bucket of dirt can produce electricity that recharges itself naturally and never sends you a bill, what else have they not told you?